Dear colleagues, we are glad to welcome you to the third day of our IntelITSIS conference. Today on our section we have 7 presentations, and let me remind about the rules of our conference. From 7 to 10 minutes for the speech, for the presentation, and from 3 to 5 minutes for questions and answers section. The first, we have the presentation by Tatiana Neskoraedova and Eugene Fedorov, the method of automatic processing of audit content based on bidirectional neural network mapping. And we have the speaker who will present it. Yeah, Tatiana, thank you.
Let me present.
Yes, you may share your screen.
Dear head and participant of the workshop, let me present a report on the topic method for automatic processing of audit content based on bidirectional neural network mapping, authored by Tatiana Neskoraedova and Evgen Fedorov. The relevance of the topic of the article is explained that the decision support system at the audit of enterprises based on
I'm sorry, Tatiana, we don't see your presentation. You didn't share your screen.
Did you see my presentation?
Yeah, now we see. Thank you.
The relevance of the topic of the article explained that the decision support system at the audit of enterprises based on automated analysis of the large volumes of data about financial and economic activity and state of enterprise. Necessity of expansion of functional possibilities, increase of efficiency, and university of IT audit. Automated DCC audit means the automatic forming of recommendable decision based on the result of automated analysis of data that improves quality process of audit. Unlike the traditional approach, computer technology of analysis of data in the system of audit accelerate and promote the process accuracy of audit that extremely critical in the conditions of plenty of associated tasks on low and middle levels, and of the amount of ethics and supervision in every task. In data mining technology audit data, the most current method is the modeling of the mapping of quantitative indicators. The mapping of quantitative indicators of the audit can be implemented through artificial neural network with associative memory. Purpose of the researches is to increase the efficiency of automatic data analysis in the audit DCC by means of a directional forward and reverse neural network mapping of sets of audit indicators in order to identify systematic misstatements that lead to misstatement of reporting. Objectives of the research formalize the content of the audit process, of the receipt of raw materials for production and the manufactured products. Choose the neural network model for mapping audit indicators, which are noisy without some noise, which in turn simulates random accounting errors, as opposed to systematic ones, which lead to distortion of reporting. Choose a criterion for evaluation of effectiveness of neural network model. propose a method for training a neural network model in batch mode, propose an algorithm for training a neural network model in batch mode for implementation on GPU, perform numerical studies. At the current slide, we present feature vectors for mapping raw materials, received, products produced, input vector element type of operation, receipt of raw materials for production, type of raw materials, set quantity, cost, and total cost of raw materials. Output vector elements, type of operation, production of finished product, type of product, set quantity of product, direct material cost for product type P of raw materials type U, direct material cost for a product type P. The full bidirectional configuration neural network, which is a non-recurrent static two-layer artificial neural network, was chosen as a neural network. FCPNN output is linear. Its advantages, unlike most NNs, are used to reconstruct another sample using associative and heteroassociative memory. Unlike bidirectional associative memory and the Boltzmann machine, it works with real data. Unlike bidirectional associative memory and Boltzmann machine, it has less computational complexity. This model performing mapping each sample X to output sample W present next formula. FCPNN model performs mapping of each output sample D to input sample V by next formula. In the work for training model FCPNN was chosen target function that indicated selection of the vector of parameter values W, V, which deliver the minimum mean square error difference between the model sample and the test sample by next formula. The disadvantage of FCPNN is that it does not have a batch learning mode, which leads to reducing of the learning speed. For FCPNN was used concurrent training, combination of training with and without a teacher. This work proposed training this model in batch mode. First phase training of the hidden layer include steps from 1 to 6. The first initialization by next algorithm. Second step, calculation the distance to all hidden errors. The third step, calculation the shortest distance and choosing the neuron with the shortest distance. Fourth step, setting the weights of hidden layer errors associated with the neuron winner and its neighbors based on K-means rule by next formula. Step calculation the average sum of the shortest distance. Six steps checking the termination condition. The second phase training the output layer includes steps from 7 to 12. 7 initialization by algorithm. 8 calculating the distance to all hidden neurons. 9. Calculating the shortest distance and choosing the neuron with the shortest distance. 10. Calculation the distance of output neurons. 11. Setting the weight of the output layer neurons associated with neuron winner and its neighbors based on Cummings rule. 12. Calculating the average sum for the shortest distance. Last, checking the termination condition. Result for numerical research present on the current slide. Computational complexity of the proposed method using GPU and traditional representing table. Conclusion. The urgent task of the increasing of the effectiveness audit in the context of large volumes of analyzed data and limited verification time was solved by automating the formation of generalized features of audit set and their mapping by means of bidirectional contact propagation neural network. For increased learning rate of bidirectional propagation neural network was developed a method based on Cummings rule for training in batch mode. The proposed method provides approximately increased learning rate in N1, where N1 is the number of neurons in hidden layer and P is the power of the learning set. Created a learning algorithm based on Cummings intended for implementation on GPU using CUDA technology. The proposed method of training based on the Cummings rules can be used to intellectualize the DCC audit. Prospect for further research is the study of the proposed method for a wide class of artificial intelligence tasks, as well as creation of the method for bidirectional mapping audit features to solve audit problems. Thank you for attention.
Olga.
I'm sorry. Thank you for your presentation. And if there are any questions, please.
Yes, I would like to ask a bit first. May I?
Yes, Tatiana.
Thank you. Thank you very much, Tatiana, for your speech. I wonder, did you test your proposed algorithm on a GPU? And if so, what GPU cards did you use to test and probably to verify some effectiveness?
Yes, Evgen Fyodorov maybe ask answer this question.
Yes, we used GPU that виконуємо паралельну редукцію, щоб підвищити швидку дію. І ми замінюємо instar outstar так на Cummings, оскільки Cummings може реалізувати як паралельна редукція на GPU. Це підвищує логарифм n по основанню 2 виходить. Тобто, дуже прискорює. Тому ми використовуємо іменно GPU. Да. Ми проводили тести, так, і воно приблизно ось так.
And what GPU card did you use? Or maybe that was Cloud Technologies?
Ні,
Маю на увазі, яка відеокарта?
ми не використовували поки ці облачні технології, ми поки що, звичайно, NVIDIA, там, GeForce, на Максвелі ми.
Okay, understood, thank you.
Thank you.
More questions, please.
Yeah, I've got one question.
Please.
So could you comment on your comparison results? So you got the slide with the comparison. Yeah, could you give some comments? Which one is better or something like that?
Ну, тут ми що зробили? Вот это P, это кількість навчальної множини, і іменно за рахунок оцей паралельної редукції, так, ми іменно зменшуємо вот это час навчання. Вот это, тут іменно паралельна редукція використовується от за рахунок ЖПУ. І ми чому і використовуємо вот это іменно коміц, да, для навчання, щоб ми от якраз.
Okay, understood. Thank you.
More questions? Dear colleagues, if there are no more questions, we ask for another speaker. Next presentation is by Eduard Manzyuk, Alexander Barmak, Yuri Krak, Alexander Mazurets, and Tatiana Skripnik, formal model of trustworthy artificial intelligence based on standardization. Who will be the speaker?
Yes, I will.
Thank you. May you share your screen?
Okay, one moment. Yes, it's good.
Yes, we can see. Thank you.
Okay. Okay. Let's start. My name is Eduard Manzyuk, Khmelnytsky National University, Department of Computer Science and Information Technology. Speech topic: formal model of trustworthy artificial intelligence based on standardization. The rapid development of AI is its use in various areas of human life puts forward new requirements for AI application. The use of AI in important and critical areas require trust in AI. In this regard, a new direction of AI is being formed. It's necessary to develop, implement, and use AI system that meets the ethical, legal, security norm of man and society. One moment. Okay, good. Next, the need to develop the basic fundamental formation of AI system led to a significant number of scientific publications and the work of expert group in order to formally present them. So the European Information Commission high-level expert group on AI in ethic guideline for trustworthy AI defines the concept of trustworthy AI as the basic for the widespread use of AI based on human-centric approach. To ensure trustworthiness, it is necessary to implement 7 key requirements, which are determined on the basis of critical discourse regarding the content of the concept. Subsequently, implement in the form of appropriate standard. Today, many AI standards are under development, some are already finished. The ISO 24028 standard described an overview of AI trust issue. The standard aims to analyze the 4 factors that influence the formation of trustworthy AI and the decision in general. The structure of the general standard and certainty of concept make it possible to form ontology of the concept of trustworthiness. The basic for the creation of ontology is the focus of determining the concept, ensuring the implementation of which in practical technical means and information technology using AI will ensure the parameter of trustworthy AI solution. The central concept of the standard is trustworthy AI, which is defined as the ability of AI to meet the expectation of stakeholders. Is very verifiable, and has the ability to implement such a check. The central concept of the standard is the trustworthy AI, which is defined as the ability of AI to meet the expectation of stakeholders, is verifiable, and has the ability to implement the concept of threats, vulnerability, and challenges is determined. The activity influence on which on AI weakens the trust of stakeholders. The purpose of this concept is to reduce the magnitude of threats, vulnerabilities, challenges, and weaken their impact of trustworthiness. Thus, it is the concept whose structural elements allow forming trustworthiness. That is, the concept of mitigation measures is the structural element for the information of the concept trustworthiness of AI. The set of concepts is formed on the basis of standard information and set of relationship between them. Thus, the concept of mitigation measures forms the trustworthiness of AI. List of concept mitigation measures is transparency, explainability, controllability, strategies for reduction bias, privacy, reliability, resilience, robustness, mitigation system, hard faults, functional safety, testing, evaluation, use, and applicability. The purpose models for the use of standard information as the next step in formalizing of requirements for AI. This makes it possible to expand and simplify the use of standard in order to accelerate their implementation in AI system. In order to verify the correctness of this approach to determine conforming component of the trustworthiness concept, experimental studies of the degree of conformity of the purpose structure to the information domain area were carried out. We use method of direct conformity and covering the competence of the use of proximity function and interpretation of principle. In the based on research and data obtained in JobinA, which globally analyzed the requirements technical standard of ethical guidelines AI. On the basis of content analysis, ethical principles, and documents in which they are meaningful are defined. The value of the certain data is that it consists of documents that are a result of extensive discussion and a consolidated opinion. That is not the opinion of the individual scientist, research, and so on, but is data on the higher level of generalization. The standard presents the concept of trustworthiness formation, which are confirmed by the content analysis of the corpus. All the concept on the ontology of trustworthiness formation has been confirmed at the level of main principle of ethics and global as the global landscape. The experiments showed the efficiency of the proposed approach to determine the model forming the content of the concept of trustworthiness based on the principles and guidelines for ethical AI. It should be noted that central ethical principle identified in the present documents and regulations, which have a relative importance of 60% are not presented in the standard. This indicated that ISO 24028 has a specialized purpose. The information content revealed by the content analysis as the level of identification of ethical principles is broad when the purpose of ISO standard. Thank you for attention. Any questions?
Dear colleagues, any questions, please?
Yeah, may I ask a question? In your research, you got a set of relations between concepts. So how do you identify these relations, or they are predefined maybe with some existing ontology?
Thank you for your questions. We use the research Job A. It was broad research that present not personal opinion, any research or group that present corpus was presented gray literature. That means that was presented by group of researchers. For example, it was institution or official documents, and we use relation between concept in that standard and that widespread researchers. So,
Thank you.
What tools are you using?
I'm sorry, can you repeat?
Які інструментальні засоби ви використовуєте?
For comparison?
Ну,
для сравнения, да? Для порівняння?
Так, так.
В стандарті описуються концепції, які являються для стандарту головними, і вони визначаються всередині стандарта. В дослідженні, які я використав для порівняння, були представлені концепції на базі сірої літератури. Сіра література – це не є концепція окремого автора, а це є офіційні документи, і шляхом порівняння змістовної частини, тобто, що мається на увазі під цим змістом, і були співставлені поняття стандарту із тими елементами, які представлені в даному дослідженні. Саме тому для порівняння було вибрано саме це дослідження, оскільки воно представляє другий рівень глобалізації в порівнянні з представленням концепцій.
Thank you.
Thank you for your question.
Thank you for your answer. More questions, please. Okay, if there are no more questions, the next presentation is by Петро Кравець, Василь Литвин, Євген Буров, Оксана Оборська, Victoria Висоцька, and Людмила Дзюбик. The topic is stochastic game model of data clustering. We invite the presenter to share the screen.
Okay, I will present this presentation. Just a moment, just a moment, just a moment. This one. Do you see my screen?
Yes, we can. Thank you.
Okay, my name is Evgen Burov. I am with Lviv Polytechnic National University, and today I will present you our research named Stochastic Game Model of Data Clustering. This is research authored by a team of scientists from Lviv Polytechnic National University, shown on this screen. First of all, the scientific problem we consider in our research here is cluster analysis. It is known that cluster analysis is a way of group objects from a specific set according to their similarity. The cluster analysis is widely used in a lot of different areas of science, such as data mining, e-commerce, natural language processing, linguistics, informatics, and so on. Generally speaking, the clustering problem can be represented as having a set of objects in the input and having a similarity measure, which is often interpreted as a distance between two objects in the space of characteristics. There is a lot of interest in cluster analysis today, and accordingly, there is a lot of different solutions, different methods developed for resolving this cluster problem, such as hierarchical tree clustering, K-means method, use of neural networks, genetic algorithm, fuzzy clustering, and so on. As a rule, The classic problems use some kind of optimization functions, which should be is maximize it or minimize it. An example of such function is shown on this screen. But in real life, many clustering problems contain an element of uncertainty. So there is, for example, missing attributes in a database or noisy data, and a lot of different kind of uncertainties. For clustering problem with uncertainty, there are also a couple of methods which was developed, such as neural networks, genetic algorithm, fuzzy methods for clustering. In our research, we follow the idea of using stochastic game approach to resolve this clustering problem. Stochastic game. So in order to resolve this problem, we need to formulate the clustering problem in the form of the game. Next, develop specific function representing, for example, winning reward functions. So the internals of this game, I would say. And next, we should develop a computer program and simulate. And in process of this simulation, we need to evaluate this game, this method. The formulation of the problem includes that as input we have a set of data points, and we should each data point has coordinates, and according to these coordinates we should place those data points in n clusters using the criteria shown here. It is in minimum, the sum of minimum distance in each cluster, and also divided by the number of clusters. And the game problem formulation. We consider our clustering problem as a game containing a number of layers of strategies or data points I have mentioned earlier, and a number of strategies which describes the distribution of data points across clusters, and also functions, loss functions, which will be used to optimize our solution. Next, mathematical model of stochastic game. We, in the process of game, players are randomly moving from one cluster to another. In the beginning, they have a pure random distribution between clusters, and after each steps, the loss function is calculated as it is represented in this slide, and you can also notice that this loss function contains a noise element like mu, which is modeled as Gaussian, this normal distribution with specific variance. And the game performance is evaluated by medium losses functions, theta e, and the game purpose is to minimize these game losses functions over time. The stochastic, in order to resolve this stochastic game, we developed defined a function of mean losses and the gradient of these functions. So this, if we need to move in the core of our proposed method, we can say that is based on gradient descent. And we obtained a recurrent dependence, which will allow us to calculate the next the values for the selection in the next step based on current values of losses and values of previous steps. previous steps. In this slide, you see the stochastic game solving algorithm, which includes the setting set of initial values, choosing the action options or our strategies here, calculating the current losses and adding to these losses the Gaussian white noise here, and computing the next the change in our strategies for the next step here, and measuring the quality characteristics. And based on the method developed, we made a couple of simulation or computational experiments here with different test cases, and the test cases presented in my presentation here is when cluster subsets do not intersect, and our simulation with a large number of data shows that results are with a large number of experiments, they converge to specific solutions. So when we have, like you see in this picture, this picture has algorithmic scale here, like algorithm time, for example, here, and this loss function, it is converges to constant value over time, which proves this that this method provides a solution over time, may be used for clustering, resolving clustering problem. And another kind of investigation, if you see in this slide, is the investigation of dependence, the number of steps performed from the level of noise, or more specifically from the variance of the noise distribution. It shows that when this variance is rather small, from, for example, from 0 to 50, this method gives a viable solution with a smaller number of steps, but when the variance grows, we need more and more steps to provide the solutions. Okay, do you have a couple of words for conclusion? So in the process of our research, we developed a clustering method based on stochastic game approach, and using in the process of numerical experiments, the simulation, we demonstrated the viability of this solution, the convergence of our method to specific solution. So do you have any questions for me?
Dear colleagues, any questions? Yes, please.
Thank you very much for your great speech. I wonder what software, and probably if it matters, and probably it matters, what hardware did you use to check and to test your algorithm?
Okay, we used a general purpose computer, and this algorithm was implemented in C++ language, in this program written in C++ language, and it was run on the general purpose computer because we have a lot of time. We didn't have real-time requirements here.
Got it, thanks.
More questions, please?
Why didn't you use midroid or density methods to deal with noise?
Okay, we will consider this suggestion, but in this specific experiment, we simply didn't select the use different methods here to deal with noise. We just modeled noise as uncertainty, so something like random factors influencing our game, like some might be hindrance, noise. Maybe this research can be followed along the lines you suggested.
Thank you.
More questions, please? If there are no more questions, the next presentation is by Yuri Krak, Alexander Barmak, and Pavlo Radyuk, detection of early pneumonia on individual CT scans with dilated convulsions, if I pronounced it correctly. Yeah, thank you. So Pavlo will be the speaker. Did I
Yes.
get it correctly? Yes, please. Share your
Absolutely.
screen, please.
Mhm. Can you see it? I hope everything is visible.
Not yet. Oh, yeah, already, yes.
Let me check the slides. Oh, yeah. So, greetings, dear colleagues. My name is Pavlo Radyuk. I am a PhD student from Khmelnytskyi National University, Khmelnytskyi, Ukraine. On behalf of my co-authors, Professor Yuri Krak presented the Taras Shevchenko National University of Kyiv and Glushkov Cybernetics Institute, and Professor Alexander Barmak presented Khmelnytskyi National University. I would like to introduce our work titled Detection of Early Pneumonia on Individual CT Scans with Dilated Convolutions. So the content of our presentation is as follows. First of all, it's motivation, problem statement. Then we shortly discuss the model and feature extraction technique, implementation details, evaluation criteria, experiments, results, discussion, of course, and in the end, a few conclusions will be made. So considering the current pandemic outbreak, the quantitative difference between infection and death rates demonstrates the vital importance of early diagnosis of lung diseases. Among others, pneumonia has been recognized as a lung disease with severe consequences. However, early detection of pneumonia is still complicated due to limited color spectrum of computed tomography scans and the low severity of the disease's features in the image. Moreover, a human factor is a common issue in early diagnosis and should be addressed by automated information systems. Therefore, early detection of lung diseases is an urgent task right now. To solve, or better say, to address this issue, the presented work aims to present an efficient early detection of pneumonia on CT scans. In addition to the various methods used in other studies, our research proposes a novel approach that allows designing the efficient model based on convolutional neural network for every person, for every individual. In general, the idea of an individual approach is schematically presented in Figure 1. So as you can see here, it consists of three main stages: image processing, model construction, and image classification. According to clinical diagnosis, pneumonia features in CT scans can be either highly compacted or diffusely distributed throughout the lung plane. Therefore, there is a need to consider the disease's features at different observation levels. So, an effective dilated convolutional operation with different dilated rates combining features of various receptive fields is utilized to detect visual deviations on the images. Figure 2 on the screen illustrates an idea of dilated convolutions with different dilated rates. The dilated convolution avoids losing spatial information about the targeted objects while providing low computational losses due to the network's shell of death. Here, we present the convolutional architecture designed for early pneumonia detection. Each feature extraction layer receives the result of the preceding layer, and its output is passed to the input of the subsequent layers. The network consists of three convolutional layers. Here you can see them. with ReLU activation functions after each layer, followed by a residual unit, Schiffer unit, that we applied based on the literature review, also followed by average pooling, second with 2 dimensions, and 2 dense layers. Such an architecture was obtained by providing different computational experiments. It should be also noted that at the preprocessing stage, the images from the training dataset were resized to 512 by 512 in order to locate an appropriate region of interest. For the pneumonia classification task, region of interest is represented as a pale mass of fluid in the affected lung. This pale area on a CT image can be extracted by the co-occurrence distribution, in essence with a square gray level co-occurrence matrix. The co-occurrence matrix is presented on the screen. Dataset. We employed the public dataset COVID-CT-B2 with 5,856 chest CT scans in total, collected from 879 patients with different pneumonia cases. To investigate early pneumonia properly, we took a subset of 3,458 CT samples with only viral pneumonia and normal labels. To measure and compare our model, we utilized several statistical indicators and set them as presented on the screen. So first of all, it is classification accuracy, then specificity, precision, recall, false positive rate, known as type 1 error, false negative rate, aka type 2 error, and Dice coefficient. So our results. In figure 5 to the left, both the training and validation curves grow to 95.51% from epoch 0 to epoch 2, as it is seen on the screen. By the end of the experiments, however, the validation accuracy stables and stops at 96.12%. On the other hand, in figure 5 to the right, training and loss validation curves demonstrate excellent convergence, probably indicated few signs of the model overfitting. Overall, the model based on our architecture could correctly identify 1,618 images as pneumonia, and also it incorrectly assigned 111 images with healthy lungs to the pneumonia class, as it is seen from figure 6. Moreover, 1,705 and 24 images were marked correctly as normal and incorrectly as pneumonia for the normal class, respectively. In our work, we compared and I'm sorry. In our work, we compared the proposed architecture based on the binary classification with well-known recognized networks such as VGG19, Inception version 4, and MobileNet version 2. The experiment results obtained by all models are presented on the screen. I would like to point out that our 3-layer CNA required fewer computational time. Here it is. Then it should be noted that the training and validation curves for all models stabled starting from epoch 20, and validation accuracy stopped at 94% for Inception, 96% for MobileNet, and 96.12% for our architecture. As you can see on the screen, the biggest, or probably say the best numbers, are highlighted in yellow. Discussion. Our approach showed low type 1 and type 2 errors with 1.44% and 6.11% respectively, which is quite good for such a small network with only 3 convolutional layers. Therefore, we may assume that according to all statistical indicators, based on the previous tables, the model based on our three-layer architecture shows satisfactory performance efficiency and can be utilized for further investigation. So, to conclude, our study addresses the digital diagnosis of early pneumonia in medical images. The proposed approach is based on CT scans classification with mild early pneumonia features using a modified convolutional neural network. Our main scientific contribution here is applying an effective dilated convolution operation to the network architecture in order to extract specifically visual deviations of early pneumonia in the CT images. Should be also noted that our computational experiments on a set of CT images and also statistical comparison with state-of-the-art neural networks have proven, at least at some point, the computational efficiency of our architecture. Overall, the proposed CNN can be an effective tool for instant diagnosis in case of the first suspicion of early pneumonia. I greatly appreciate your attention and eager to answer all the following questions.
Thank you for your presentation, and we are expecting questions from the participants of the conference. Dear colleagues, please.
Why did you use dilatation?
We applied dilated convolutions and dilatations in general because it allows store space information without huge computational resources. Instead, we could use a huge amount of layers in order to extract all the necessary features, but in this case, it would require huge time. So dilations, or better say dilations, allow extracting different features from different sizes, like one-dimensional, second-dimensional, third-dimensional, and so on, but do not require a huge amount of convolutional layers. So it's kind of trade-off, but in this case, it is a positive trade-off.
Usually subdiscretization used.
What do you mean, in a convolutional layer?
No.
Or after it?
No, convolution layer, subsampling, subdiscretization.
Well, of course, agree, but in terms of show some novelty in our work and demonstrate, or better say, address simplicity and efficiency, we applied this kind of convolution probably to compare it with others. And as it appeared, dilated convolutions also show good results.
Thank you.
Like it wasn't best approach, but just one of possible approaches to apply to convolutions and to see what we can achieve with it. And it appeared that the result quite impressive and can be used for further investigations, as I said before.
Thank you.
More questions, please?
Too.
No more questions. Okay. Then our next presentation is by Nikolai Rudnichenko, Vladimir Vychuzhanin, Natalia Shabaeva, Svetlana Antashuk, and Igor Petrov. The topic is Intellectual Information System for Supporting Text Data Rephrasing Process Based on Deep Learning. We invite the speaker to share the screen.
Yeah, thank you. I'm ready. Just a second.
Yes,
Everybody
we
can
can
see?
see.
Okay. So, good day, dear colleagues. I'm Brudnichenko Nikolai, and I would like to report the results of our science work, intellectual information system for supporting text data, rephrasing processes based on deep learning. Currently, there is an active growth in amount of data created and posted in the internet space in various applied topics. This is largely due to high demand from customers for various goods and services in useful content. The largest volume of content circulation in the internet belongs to different kinds of content, multimedia, text, data, and different materials. One of the most critical shortcomings of studying and analysis of this kind of content is a high time spent on the full reviewing, as well as a need to use both visual and auditory perception, which is not always effective and justified. So in this regard, tools, technologies, methods, and systems for automating the processes of generating text content, its syntaxes, punctuation, and grammar processing, natural language processing, assessing the level of uniqueness and other indicators of the quality of the materials obtained becoming increasingly important. The purpose and objectives of our work, as shown on the slide, is to develop and study the intelligent information system for supporting the analysis and paraphrasing processes of heterogeneous text data based on the use of deep learning capabilities to improve the quality of created paraphrases. And the main work objectives we did is analysis of literature, information system project development and implementation in code, and created and researched deep learning, deep neural network capabilities and efficiency in our system. Due to the development of our AI concepts, a variety of application system tools and means are being created to provide the process of intelligent processing and analysis of textual information in natural language. But their efficiency for large amounts of text data is often low, including due to impossibility for providing functions in generating complete and coherent sentences or phrases for a given subject area, taking into account its specificity and syntaxis rules in particular language. To solve natural language processing problems that we discussed, paraphrasing in particular, based on the use of natural networks. Various architectures are used. The most popular and effective in practice in such field are recurrent neural networks models, in particular LSTM, and networks of the transformer type. We did such models in our previous science work, so we would like to compare them in this one. Data set we use for training and studying and researching our models is para and MT50M. It's about 50 million paraphrases data set, and we use it. Project development tools we use are shown in the screen is Python 3.7 programming language to write a code, Django framework to make our system deployment view production to use it in the interface of a web application. PyCharm IDE, Postgres SQL, Anaconda and Jupyter Notebook for discover and research the models and to build models. PyTorch, also the library as a sklearn, Matplotlib, Pandas, and NumPy. On this slide, we can see the diagram of main use cases of our system that we create. It's a system contains two different types of tasks. The first one is to business type of tasks. It's to registration, authorization, and find in a system different users real users, real men to discuss, to have a conversation. And the second one is create and choose a bot, which actually use our natural networks as the base to generate their phrases and to discuss with the user. User interaction with the system shown at the screen. There are 5 main ways to interact: going to web page in the system through a browser as a URL with a registration, authorization in the system, selecting operations, go to the page for searching interlocutors, managing personal data created by chat, viewing the communication history, and choosing a chatbot. Chatting with a person and interaction with the chatbot, as I would say. On this slide, we can see the diagram of system, not use cases. I'm sorry, it's a component diagram. We can see that the user accesses the main chat app component, which is responsible for the relationships and interaction with the chat. Chat profile, chat history components with each other. The chat component is responsible for sending and receiving messages to collect data. Chat profile implements the functionality of the chat state according to the user's profile, and chat history provides serialization, deserialization, and storage of data. The next slide, it's experimental hyperparameters, which we used for creating LSTM model. There were 4 different experiments, and the first and the last one list of hyperparameters and optimizers are shown here. First one, we used optimizer SGD, and in the last one, we used optimized the Atom. It was interesting results. We can see on the such slide, LSTML models learning error dependencies. We can see on the X line, we can see the 1,000 of our epoch. Based on results in the first experiment, for example, it can be answered that LSTM model was trained about 10,000 epoch. The value of this was scaled 1 to 1,000. The value of loss function gradiated dropped to 5.3 on the validation set, and should be noted starting from the 5,000 epoch, as indicators of loss function sharply deteriorate, which may due to the high value of the model learning rate. And there were four such experiments. The next, our step is to discover the transformer as specified hyperparameters. We used we made 2 different experiments with such a model transformer, and the values are shown in this slide. We can see, based on such experiments, we have error dependencies shown in this slide. Here we can see the transformer models are better for our task, and according to the experiment, the best loss function in terms of indicator of the transformer model, the level of which was reduced a minimum value of 0.6. There were more than 10,000 epoch, but we shown here about such quantity of epochs as in the previous LSTM. But if we can see the full graph, there will be about 0.6 error values. But it's not enough actually for our research to use only previous metrics. We need to use metric values. It can show us more specific efficiency of our models. And we can see that the results of evaluating of blue metrics is for the created neural networks shown here. As we can see, the transformer model shows the best result in solving a problem and generating paraphrases. Its value about 46.7. We would like to say it in conclusion that based on the practical use of development system in various scenarios for different texts, it should be noted that the basis of transformer models on average in 7 out of 10 cases, paraphrase is generally generated correctly and satisfy all our expectations. For LSTM models, this value is low, about 3, 4 out of 10. It should be also noted that all generated sentences with the framework of the study are complete and they have a meaning close to the initial sentences, which is confirmation of the correctness of the aggregation of taking data set. And we would like to say that the experiment results obtained allow us to reveal the greater accuracy of transformer model for rephrasing task of natural language processing compared to LSTM. And there are some future useful ways to research in this field. We plan to increase the efficiency of the search for borrowings in text to train our model and use our information system to add the functionalities in our information system. To automate the detection of duplicates in text data by indirect occurrences and to automate the process of supplementing training data in machine translation systems. I believe that's all. Thank you for your attention. Please, any questions?
Thank you for the presentation. We have one question, please. 2 questions. Who will be the first?
Evgeny, you was the first, so it's your turn. No? Okay, I may start.
Okay.
Thank you very much, Nikolai, for your great presentation. Maybe I missed it, but you showed in the slide of hyperparameters different scenarios. Yeah, I wonder, did you choose these values on your own, or probably, did this sort of hyper-tuning and hyperparameter optimization on your own, or maybe used any additional libraries to automate this process?
Thank you. Actually, it's a really good question because a lot of work to choose it by own hand and just by own hand. Of course, we discovered the ways of how we can do it. Firstly, when we analyzed the science works in this field, I don't really remember in what work we saw such list of hyperparameters, but there was a different work, not about rephrasing, but different NLP case. And we used in first, for example, for the transformer, that slide I opened, we used in first experiment the values from their state, but we discovered that it's not the best values for our task. So we, of course, use tuning using cross. For the moment, I forgot cross grid search. Yes, grid search to find optimal hyperparameters for the model. But the finding wasn't really excellent. I mean, it works, and we use the values that we have with tuning. But still, there were another experiments I didn't match in this slide and this work. They show that a little bit, kind of 10 of one lower than 1%, but we can upgrade the accuracy of model based on results of tuning. But I don't remember dropout. If I don't, if I'm wrong, dropout value was we changed dropout value a little bit, and it shows us a little bit more efficiency, but it wasn't really high. So we discovered to use this values.
Yeah, thank you. From my perspective, generally, neural networks provide really high metric values, although require huge work on this tuning. So it's a real pain in the neck, always,
Yes.
almost always.
Yes.
Thank you.
I would like to add that we just haven't got any big capabilities of calculating process. So we used Google Colab to help us because work with 50 million paraphrases, it's real hard in modern, in home computer or even in a university computer. Thank you.
Yeah, Google Colab is a good option.
Yes.
Agree.
Why did you choose PyTorch instead of Keras or TensorFlow?
Oh, that's great. The great question. And in our business cases, we work with our students in our university, in our cathedra. When we use Keras and TensorFlow, that's a great instrument, tools for natural networks, for machine learning, but it's really hard. It's really hard as our experience shown to debug such models in production. When we not just create a notebook with model, a Jupyter notebook with model, and to discover, but when we need to build our model and to reproduce it in production to use for business cases such as our system for using by different users. PyTorch is better in debugging mode. Only because of it, we use PyTorch. Plus, when we use PyTorch, we didn't discover actually and didn't research, didn't measure. Is it PyTorch models faster than Keras, or we didn't evaluate it. But according to our researches and analysis in literature, PyTorch maybe a little bit, even a little bit more, have more efficiency in speed when we use it in production products which are deployed as a web application.
Thank you. And as a question, why did you choose LSTM instead of Zerunu gated recurrent unit?
Yes, the thing is that in our previous works, when we researched the sentiment analysis and analyze of tonality of text, we used different. For the one for one work, in one work we use LSTM, and it shows us about 95–96% efficiency. In the second case, in a different work, we use transformer. Also for NLP case, and it shows us about 92% in that task. And we would like to discover both of these models in our one project to compare it. Of course, we might use the architecture, as you said, and different models. It's, I believe, this will be the next step in our research works later. But it was more convenient for us in this task in rephrasing to use such models because we have a good experience in our previous cases, how to create and deal with these models.
Thank you.
Thank you. More questions, please?
Yeah, may I ask a short question if there is some time? Question about your data set. You state that it consists of 50 million of paraphrases. It is interesting how you got these paraphrases. Maybe it's the result of your previous research.
Thank you. No, this data set wasn't used in our previous research. We find two actually data sets for our work, but we choose this one because it's more more convenient through the statistical well, it's more convenient because first of all, it's large data set. The second one is has different paraphrases and different sentences and different language specificities. And the third one, its structure inside is good for analyzing and for building models to discover, to research it. Of course, we didn't use it as one file because it's very big data set. We used Google Colab options to include and import this data set from repository, which we found, because its data set it's free in open source. Everybody can use it, but it's hard to use it on your own PC. But it's comfortable use it in cloud services such as Google Colab. So I believe I answered your question.
Yeah, thank you. I understood that it's not your own data set, but it's a existing free data set to use. Yeah, thank you.
Yes, and I would like to add one little sentence that all data we have when we use our system for chatting, when the user puts some text into our system, it also saved and it might be added for our main data set to make it more widely, more representative. So we, on basis of this data set, we multiply, we adding the data that we collect through our web application. Thank you.
Thank you for your presentation and for the questions and answers. The next speaker is Alexey Kozlov, and the topic is optimal selection of membership function types for fuzzy control and decision-making system. Are you ready?
Hello, dear colleagues. Yes, I'm ready. Now I will share my screen.
Please. Yes, we can see it. We can see the presentation. Make it in a full screen mode, please.
Yes, one moment.
Thank you.
Okay, the topic of my presentation is optimal selection of membership functions types for fuzzy control and decision-making systems. The structure of the presentation is as follows. Introduction, the problem statement, intelligent approach for optimal selection of linguistic terms membership functions types, optimal selection of membership functions types of fuzzy control of the mobile robot, and conclusions. The fuzzy logic is a popular and powerful tool now for automation of control and decision-making processes, which has a great potential. Intelligent control and decision-making systems based on this area of fuzzy sets and fuzzy logic are widely used in the following areas, such as industrial automation, transport logistics, medical and technical diagnostics, financial management, stock market forecasting, and others. In particular, fuzzy inference devices are successfully used to apply as controllers, observers, adaptive devices, identifiers, tactical control units, and others for automation of complex and non-stationary plants such as robotic production lines, power plants, chemical reactors, mobile robots and drones, and some others. An essential feature of fuzzy systems and devices is a large number of adjustable parameters and structure elements which significantly affect their performance. Namely, the following are the subject for adjustment: the number of linguistic terms of input and output variables, as well as the types and parameters of their membership functions, the antecedents and consequence of the rule base, the number of the rule-based fuzzy rules, the input normalizing coefficients, the types of aggregation, activation, and accumulation procedures, as well as the defuzzification methods. This allows to implement complex, flexible, and most effective strategies of control and decision-making, but it also significantly complicates the design procedures of these systems and devices. In recent years, one of the leading research directions of the modern area of fuzzy systems is the development and approbation of highly efficient approaches, methods, and information technologies for their design, which include certain procedures of structural parametric optimization. Modern fuzzy systems are developed mainly with the help of advanced computer-aided design methods, which contain structural parametric optimization procedures. The cutting-edge studies show that the bio-inspired intelligent methods and information technologies are very promising for performing fuzzy systems design and optimization, and have a number of advantages compared to conventional optimization techniques. These methods can be conditionally divided into two main groups: evolutionary methods and multi-agent methods. The given bio-inspired methods can be effectively applied for optimization of different parameters and structures elements of fuzzy systems. This study focuses on solving the challenge of linguistic terms membership function optimizations based on bio-inspired techniques, in particular optimal selection of their types. These allow not only to improve the efficiency of the fuzzy system itself, but also to simplify the further procedure of its parametric optimization by reducing the number of optimized parameters of terms. For example, linguistic term with triangular membership function has three tuned parameters, A, B, and C. The trapezoidal function has four parameters, and the Gaussian type 1 function has only two parameters, A and B. In this work, the advanced intelligent approach for optimal selection of membership function types of fuzzy systems based on bio-inspired optimization techniques is proposed. It contains from the following steps: setting of operating ranges of input and output variables changing of the developed system, formation of the set of membership functions used in the optimization process, selection of the number of linguistic terms of the fuzzy system input and output, setting of parameters initial values of the linguistic terms membership function, formation of the vector S structure which determines the set of membership functions, selection of the initial hypothesis for the vector S, formation of a complex objective function, conduction of an iterative global search for the optimal vector S using one or several bio-inspired intelligent algorithms, and finally analysis of the results obtained and selection of the best variant of the membership functions types vector. At the second stage, a set of alternative membership functions is created, which include the most frequently used functions, such as triangular, trapezoidal, bell-shaped, Gaussian first and second types, P-shaped, S-shaped, Z-shaped, sigmoid, double sigmoid difference function, and product of two sigmoid functions. The number of adjustable parameters K and F of these functions are shown in the table. The vector S formed at the stage 5, which determines the set of membership functions for the developed system, has the following form. Also, the complex objective function formed at the stage 7 consists of two criterions. The first criterion, which calculates the performance of the fuzzy system itself, and second criterion, which takes into account the degree of complexity of further parametric optimization of the system being developed. For example, when designing a fuzzy control system, the first criterion can be presented as the generalized integral deviation of the real transient response of the system from the desired transient response of its reference model. In turn, the second criterion calculates the number of optimized parameters of linguistic terms depending on their membership function types. The efficiency research of the proposed intelligent approach is performed in this work at optimization of the membership functions types for a fuzzy control system of the clamping device for a mobile robot to vertical movement. The considered mobile robot moves by means of wheeled propulsors and uses the electromagnetic clamping device to hold on vertical and inclined ferromagnetic surfaces when implementing different types of technological operations, such as painting, welding, rust removal, inspection, and so on. The clamping device must provide a certain value of the clamping force for safe and effective movement of the robot on various surfaces under the actions of different disturbances. Here you can see the 3D and physical model and some equations of the clamping force mathematical model. These slides show the functional structure of the fuzzy sliding mode control system of the robot's clamping device, the main equations of the conventional sliding mode control, the sliding surface and controller, and the rule base of the fuzzy sliding mode controller that gives the opportunity to implement the given control law using the fuzzy inference. The developed intelligent approach is applied in this work to optimize its linguistic terms membership functions. For the controller inputs, error and its derivative, 5 linguistic terms are selected for each: big negative, small negative, zero, small positive, and big positive. And as for its output, only 3 terms are chosen to implement the sliding mode control strategy: negative, zero, and positive. Initially, all these terms have the triangular type of the membership functions. So now the vector S is its initial hypothesis is formed as follows. As the complex objective function and its component, the given above at slide 8 criterions are used with the following optimal values. For the global search of optimal membership functions types, 3 bi-inspired algorithms are implemented in this case, which are previously adapted for this task: genetic algorithm, biogeography-based algorithm, and algorithm of artificial immune systems. The adjustable parameters are set as follows. This slide shows the linguistic terms membership functions types optimization results, in particular the convergence curves for each algorithm and the best found variant of the vector S. As can be seen, the best optimal variant is found by the biogeography-based optimization algorithm at the 72nd iteration. This slide shows the linguistic terms of the fuzzy controller with membership functions of triangular types before optimization and obtained optimal membership functions found by the biogeography-based algorithm. As can be seen, the optimal variant of the linguistic terms membership functions allows to provide significant decrease of the objective function value and its separate components. Also, the total number of parameters of terms is reduced by 7 parameters. For triangular types, it was 39, and now it is 32. Here you can see the transient graphs for the control system of the mobile robot clamping forces for 2 cases: with fuzzy controller with triangular types and membership functions, and fuzzy controller with optimal types of membership functions. As can be seen, the clamping force control system with the optimized membership functions has higher quality indicators in comparison with the same system with the triangular basic functions. In particular, the static error is significantly decreased with the same time of transient. So the results of the obtained work in this research confirm the high efficiency of the developed approach for optimal selection of membership function types, as well as experience with its application for structural optimization of different types fuzzy systems. For the given specific example, for the sliding mode fuzzy control of the clamping device, the BBO algorithm show the best results as it's provided the fastest convergence and the highest performance. In turn, genetic and immune algorithms also show satisfactory results, since they also made it possible to attain the optimal value of the objective function, and this they used acceptable computational costs, which in general also confirms its experience of its application. And in addition, the controller with optimal membership functions obtained by the presented approach have fewer parameters that need to be optimized at further parametric optimization procedures. Thank you for your attention.
Thank you for the presentation. And we have one question. Evgeny, please. Evgeny, turn on your microphone, please. We saw your raised hand to, yeah, thank you.
Why are you using meta-heuristic instead of backpropagation algorithm?
Because meta-heuristic bi-inspired algorithms can find better solutions because they more specifically search the search space and may find better solutions because they are methods of global optimization.
Thank you.
Thank you for your question.
Thank you. More questions? Dear colleagues, if there are no more questions, we go to the last presentation of our section by Vsevolod Sinkivsky, Irina Pich, Sergei Babichev, Alena Kudryashova, and Natalia Sinkivska. The topic is modeling of alternatives and define the best options for website design. We invite the speaker to share the screen.
In just a moment, we are going to share the screen.
Okay, Alexei, please stop sharing your screen to allow this opportunity for other speakers. Thank you.
Do you see it?
Yes, we do.
Okay. Good afternoon, everybody. My name is Natalia Sinkivska. I represent the Ukrainian Academy of Printing. As you may see, the topic of my speech will be modeling of alternatives and defining the best options for website design. The problem of the quality of printing products and processes related to its manufacture hasn't lost its relevance in modern world. But nowadays, users are focused mostly on the internet resources which widely replace the printed media. That's why the quality of the development was the topic of our investigation. The quality of electronic web resources depends on the modes selected for the implementation of electronic resource design processes. The efficiency is certainly determined by the conditional numerical expression of factors on the alternative efficiency of fuzzy ratios of advantages in the projected variations at the absence of numerical expressions of the factors participation in the process of website development. Of course, the initial stage of solving the problem is to distinguish from the general set of factors that dominates the others by the influence, and that is the factor with lower weight priorities are removed from further consideration. The limitation of the number of factors is justified by the use of the Pareto principle. Its application simplifies the process of alternatives development and ensures sufficient quality of the results for practical use. To model alternative variants of the site development and to identify the optimal one, we used two different methods, namely the methods of linear convolution of criteria and the methods of fuzzy relations of advantages. Coincidence of the results obtained by both methods proved the validity of performance investigation. The main goals of our research were to highlight factors attributed to the Pareto set having a prevailing impact on the website development process, to calculate the usefulness of alternatives by measuring the importance invariance, to find the optimal option for the implementation of the process at the maximum value of the utility function of the combined target functionals obtained on the basis of the methods of linear convolution of criteria, to confirm the reliability of the obtained results using the multi-objective optimization method, to build the matrices and convolution of relations, to calculate the functions of convolution affiliations and the maximum value of the affiliation of the set intersection function of a nominated alternative determines the best option. Let's describe this process. So let the Pareto set be expressed by the factors F1, F2, and F3, and F4. F1 stands for the site content. It means text, illustrations, diagrams, tablets, etc. F2 stands for the usability of website design and interface. F3 is information security, protection from unauthorized access. And F4 stands for the performance response time for the user comments. We give three alternative options for the implementation of the design process, marking them 1, 2, and 3. The assessment of the alternatives by formally expressed measures and importance of the selected factors will be reflected in the table 1, which is presented on the screen. Table 1 introduces the following symbols. WFI is the starting or initial weight of the I factor. PIJ is a measure of assessment as a percentage of the importance of I factor in relation to the J alternative. And according to the logic of the method of linear convolution of criteria, we build the table 2 to evaluate the alternatives by factors keeping the weight values mentioned above. Simultaneously, we arrange combinations of assessment of the factors share in the alternatives, and you can see the table 2 on the screen. Factors specified in table 1 are considered the starting set with the initial weight values. For further research, according to the second column at the society comparative scale, we build the matrix of period comparisons in the table 3, which is on the screen. And after its processing, we get the refined values of the Pareto set factors, WI, suitable for calculating utility functions. Thus, the matrix of pair comparisons for the site content factor F1, considering the percentage of its effectiveness in the alternative, will look like this, represented in the table 4. After processing the matrix presented in the table 4, we get the values of the variant utility functions by factor F1 and corresponding criteria, which you can see on the screen. Lowering similar metrics of pair comparisons for the factors usability, information security, and performance, we offer the results of the processing, which you may see on the screen as well. According to the obtained functions of the utility and weight priorities of factors, we get the final values of the combined functionals represented on this slide, and the maximum value of the utility functions UI of the combined partial target functionals determines the best option for the implementation of the website design process. As a result, we find that the site content factor has a decisive measure of influence on this process. Modeling of alternatives by multi-objective optimization methods consisted in the following. Since the initial criteria for the multi-critical alternative problem are the factors of the Pareto set, it's necessary to convolve many criteria into one scala. To do this, we use the method of intersection. So experimental determination of the optimal variant of the site quality development by multi-objective optimization method can be performed through the step-by-step implementation of the following algorithm. In step 1, we establish a set of alternative X, and for each of the factors of the Pareto set, we establish fuzzy advantages ratios between variants that will be identified by mnemonic names of the factors. During the step 2, we find a convolution of fuzzy relations of advantages between variants. Then in step 3, we establish a set of undominated alternatives with appropriate affiliation functions. And step 4 is to find an additive convolution of fuzzy relations with functions of affiliation for the convolution Z2. After that, during the step 5, we determine a set of undominated alternatives for convolution Z2. And finally, in step 6, we are looking for a common set of undominated alternatives as the intersection of sets Z1 and Z2. And it means that the alternative having a maximum value of relations functions will be optimal. Based on the above mentioned algorithm, we will choose an alternative using the specified method and find the best options for website design. Let us have a set of alternatives X. And according to step 1, we leave without changes the factors of the Pareto set, which determines the total relation of the advantages and the weights obtained earlier by the priority of factors having influence on the website development. Fuzzy relations of the advantages between the options website content, usability, information security, and performance are represented on this screen. According to the above mentioned relations, we build the matrix of relations for factors F1, F2, F3, and F4. And which is simultaneously determine the functions of affiliation to the advantages of alternatives by factors. You may have a look at the relation matrix of the advantages of the relations by F1 factor. The same relations matrices have been built for the rest of the factors. In accordance with step 2, we specify a convolution of relations for which the matrix of values of affiliation functions is represented in the table, which you can see on the screen. Step 3 involves obtaining the values of the affiliation functions for each of the alternatives. Generalization of the performed calculations gives the result of step 3 presented on the screen. The next algorithm procedure, step 4, is to find a fuzzy advantage ratio Z2, that so-called additive convolution of relations. The results of calculation of the values of convolutional affiliation functions will be displayed in the table, which you can see on this slide. And in step 5, we find a set of undominated alternatives for Z2 convolution, and as a result, we get the values 0.8, 0.2, and 1. And the last step 6 is to find the convolution. That's why considering all three values of the convolution function Z1, which are equal 1, we can assume that 0.8, 0.2, and 1 are the values of convolution functions of sets intersection Z. Z convolution functions indicates that the best alternative to the design process of a book edition with the above-mentioned advantages of the utility of factors is the third X3 variant, as its relation function has a maximum value. The obtained data confirms the accuracy of the results of investigation, since the best option for designing a book edition calculated above by the method of linear convolution of criteria is also the third option. The expert developers and users of websites have the same opinion, which coincides with theoretically obtained conclusions. And to sum up, I can say that the results of application of the proposed methodology was a revealing of analytical and algorithmic support suitable for the development of alternatives and optimal options fit for the development of electronic products, which with evaluable content, compositionally complete, protected from unauthorized access, and convenient to use. We established that the separation of factors of the so-called Pareto set was an important initial condition of the process, and for theoretical background and effective design of the alternatives, we used the following methods. Methods of analysis of hierarchies, which ensured obtaining of priorities of the identified factors through the construction and processing of pair comparisons matrices, and methods of multi-criteria theory of utility and multi-objective optimization theory. The formulas for practical calculation of the values of utility function and functions of the affiliation have been given, allowing to make a decision about the best options for the implementation of the website design process. Obtaining the same decisions but two methods used to determine the optimal implementation of the website development process indicates the proper reliability of the results. That's all. Thank you for your attention. Please, questions.
Thank you for your presentation. We have raised hand for the question. Please, Evgeny.
How do you automate the procedure for identifying the
Repeat, please.
SF membership functions?
I'm sorry, I misunderstood. Can you repeat the question?
Ну, як ви автоматизуєте процедуру ідентифікації параметрів ваших функцій належності?
Actually, we are planning to continue our research, and it will be our next step in the research.
Thank you.
Thank you for your answer. More questions? No more questions. Dear colleagues, thank you all for the presentations. Thanks to all the participants for great speeches and discussion. We invite you all for our awards and closing ceremony, which will take place at 4 p.m. On this link. So see you at 4 on Zoom.
Now we have a lunch. We will continue our section first at 2 p.m. We invite everyone to continue working. Bon appetit for all.
Thank you.
Thank you.
Thank you.
Thank you. Thank you.
Thank you. See you in a minute.
Bye.
Thank you.